Good evening, class. We are looking at sequences and series. So we are going to look at the concept of sequences and series, arithmetic sequences and series, geometric sequences and series, and binomial theorem. Very straightforward, all of which we have seen before. So again, the synopsis here about the vector properties, everybody remembers them. Okay, addition of vectors and scalar product. Conic sections consist of circles, ellipses, hyperbolas, and parabolas. And again, to be able to handle that, you should remember the midpoint formula and a distance formula. All right, so let's get this started. Okay, in this page, we have the synopsis of the section. Okay, and it gives us really an overview of what's coming up. First and foremost, it is important for everybody to know what we mean by sequence. Sequence is simply a list of numbers. We start with a sub 1, a sub 2, and we move on. That's the first term, the second term, and then a sub n, which is the end, which is known as the general term. Now, when we write a sequence, we can write it in a recursive format, which means one depends on the previous one. A sub n plus 1 is f of a sub n is called, or we may not. We have a finite sequence which has so many terms, or we have an infinite sequence which continues indefinitely, and its domain is a set of natural numbers. Later on, we'll discuss this with more details in calculus, the idea of convergence versus divergence. When you can come up with the limit, in other words, as a sequence continues indefinitely, if it ends up being a number, any number, then we say it converges. When the way we write it is the limit of a sub n as n goes to infinity is L. And if it either goes to infinity or negative infinity, or if it oscillates between two numbers, we say the sequence diverges. So this is the idea behind this concept. Although arithmetic sequence and geometric sequence are the sequences are coming up, but I want to explain something right here because you've seen this. There is nothing brand new here. And again, we repeat that when we come across it. An arithmetic sequence, okay, basically starts with a number and we keep on adding a number, okay? So we have the first term and we have a common difference, we call it, okay? Difference or a common difference, okay? So when that happens, the general for a sub n, all you have to do, add d to the previous one. This is a recursive format. So pick one, add the difference, and it becomes the next one. Okay. A simple example of that, we are just adding 4. As you can see, we are adding 4. But the explicit format, if you recall from algebra, a sub n is a sub 1 plus n minus 1 times d. That's the explicit format. Okay. Now, in the case of a geometric sequence, what happens instead of a common difference, we have a common ratio, if you will. Ratio. Okay. So whatever the first one is, the next one gets multiplied by that common ratio. Okay. So with that being the case, if the first one is a sub 1, the next one gets multiplied by something, and this thing continues. And because of that, this is the general term, the nth term of the sequence explicitly. However, if we want it recursively, basically pick one and multiply by r. Pick one and multiply by r. Example, 1, 4, 16, 64. Everything is being multiplied by 4. By the way, if you're given a sequence and if you're claiming it's an arithmetic sequence or a geometric sequence, you're going to be able to come up with those. And I highly recommend you don't stop by looking at just the first couple of terms. Look at quite a few more to be on the safe side. We are basically repeating the definition here, so I don't want to really waste time. A sequence is just a list of numbers. I'm reminding you of that. And again, we have the first term, the second term, and the general term. And what matters is the domain is a set of natural numbers. Okay. Now, let's make some sense out of this by looking at a few very simple examples. We want to find the first 5 terms. Okay. Now, I want to start with a very simple one. A sub n equals n. It simply means replace the n with 1, 2, 3, 4, 5. And I hope you see this answer. We really don't want to waste time. It's that simple. But let's discuss part B because, okay, it's worthwhile looking at. Sine of n pi over 2. Okay, so that means you replace the n with 1, you get sine of pi over 2. With 2, you get sine of 2 pi over 2 of pi. And you continue until you get to number 5. Now, it's one of those common arcs. They are simple. Everybody remembers that, okay? And I hope everybody remembers that sine n pi. We are saying n is what? An integer, is 0. And then sine of 2n plus 1 times power 2, it goes to -1 or +1. For example, sine of power 2 is +1, but sine of 3 power 2 is -1. So that's something everybody's familiar with, and we end up with the following answers. So pi over 2 is 1. That's what the sine is. Sine pi is 0. Sine of 3 pi over 2 is -1, and so on and so forth. Okay. Any questions? Everybody clear? Everybody's fine with that? Class?
Yes, thank you.
My pleasure. And so let's go look at part C. What happens in part C, it simply means, okay, C sub n, the general term is defined as n over 1 plus n, so replace the n with 1. You get 1 over 1 plus 1, or 1/2. Replace it with 2. 2 over 1 plus 2, or 2/3. And I hope everybody can easily see the answer, which is the following set: 1/2, 2/3, 3/4, 4/5, and 5/6. It's that simple. And we're done. Now, the last one is asking for the digit in the nth decimal place of pi. And it's extremely important for you as a pre-calculus student to remember pi is not 3.14. Pi is being approximated by that. But what is pi equal to? 3.14159, and it continues indefinitely. Okay, class? So with that being the case, we want the digit in the nth decimal. So for example, the very first one, the first decimal is 1, and the next one is 4, and the next one is 1, and the next one is 5, and so you get the picture. We want only 5 of it. Okay? Sounds good? Everybody's okay with that? I hope you see it's very straightforward, very simple. Okay? So just in case, a question like this should be easily handled. Just, plug in and you should have no problem handling it. I'm saying, for the final, when we add a couple of questions from the new stuff, okay, as an example. Okay. Here's the next one. 2 to the power of n minus 4 represents the general term a sub n. That's the general term. Okay. So what we need to do is to come up with a few terms here. In this case, we want 5 of it. Okay. So let's give everybody a moment to figure this out. For example, if we replace n with 1, we get 2 to the power of 1 minus 4, which is 2 minus 4, which is negative 2. If we replace it with 2, we get 2 squared minus 4, which is 0, so on and so forth. As long as you can calculate 2 terms, you can calculate all of them. So the rest shouldn't be a big deal. And so you would write it as the following set for the first 5 terms. Okay, everyone? Does that make sense? Is everybody okay with that? We're going to move on. And make sure everybody is done with this, right?
Yes.
Perfect. All right. Now we're going to go to the reverse process, and I want you to know sometimes the reverse process is pretty difficult. We want to find the formula for the general term a sub n of the sequence, and because it's one of those that we have seen and it was discussed, we can easily see what happens with the first case. So in part A, we notice it's a special case of a sequence. Can anybody tell me the name of that sequence? What do we notice for part A? This is a arithmetic sequence because when you start with the first one, a sub 1 being 5, then all you have to do, keep on adding the same number. So 5 plus 3, 8 plus 3, 11 plus 3, and so forth. And because it's an arithmetic sequence, then you can use the formula for the arithmetic sequence for a sub n, which was given as a sub 1 plus d times n minus 1. You can use that because it is an arithmetic sequence, okay? And so you're going to replace each one accordingly. So a sub 1, which is 5, and d, which is 3, okay? And when you work it out, 5 plus 3n minus 3. And so a sub n has this general solution that is 3n plus 2. A sub n is 3n plus 2. All right. What do we notice about the next one, part B? Can anybody tell me what we notice about part B, class? What are we dealing with?
Multiples.
This is a sub 1. If you divide, okay, here's how you do it. You subtract, you see it doesn't work. If you divide the first by the second by the first, the third by the second, the fourth by the third, and so on and so forth, you notice that it's a constant number, negative 1/3. Do you see the ratio of negative 1/3? In other words, keep multiplying by negative 1/3. From the first one, you go to the second one. The second, negative 1/3 times negative 1/3 is positive 1/9. Positive 1/9 times negative 1/3 is negative 1/27, and it continues indefinitely. So that shows that you're dealing with the geometric sequence. The ratio is constant. Okay, class? And so with that being the case, we can look at the general term. If you recall, the general term was a sub n is a sub 1 r to the power of n minus 1. It's one of those formulas we need to remember, and you're going to have a lot of usage for this when you get to calculus 2 and you deal with the sequences and series. I highly recommend you just remember this for that course. And so with that being the case, let's plug in. A1 is 1, r is negative 1/3 to the power of n minus 1. Okay, and so you can rewrite it either way. Now, one of the things I want you to pay attention to, so basically I'm using the formula. A sub 1 is 1. Okay, that's, and then r is negative 1 to the power of n minus 1. Now, why am I writing it in this fashion? And you'll see it when you go to to calculus 2 and we use sequences and we look at the concept of convergence and divergence. This is known as alternating sequence. Alternating sequence means the sign changes. So if you're given a sequence and you got to figure out what type, there are really two ways. Look at the sign separate from the rest of it sometimes. And that, with that being the case, the sign is always negative 1 to the power of n or negative 1 to the power of n minus 1. Why is that? See, if we choose this one, for n equals 1, the first term becomes negative because negative 1 to the power of 1 is negative 1. So for our sequence, because it starts with a positive 1, I'm looking at the sign only, that doesn't work. So what works is this one. Now, this, in some instances, you may see negative 1 to the power of n plus 1. It results in the same answer. Negative 1 to the power of n plus 1 will give you the same answer as far as the alternating part, okay? So that's important for everybody to see. But what it doesn't do for this one, it doesn't work for the first term. This, I'm talking about the sign when it alternates, okay? All right, I think we are okay with that. We're going to go to the next example. Okay, everybody? We want to find the formula for the general term for each case, or A sub n. Let's see if they are straightforward and we follow that. So in part A, what do we notice?
Numeric order.
Okay, so what would be the general term? If you change the first one to e to the power of 1 over 1, would that help you see the general term, class? The numerator is e to some power. And what power is that? 1, 2, 3, 4. And the denominator is the same numbers, 1, 2, 3, 4. So do you see this as the answer, class?
Yes. Yeah.
Good. All right. What do we notice about part B? What's going on? I hope you see that it's very similar to the question we just did. What type of a sequence is that?
Like.
Multiples of 3?
Mm-hmm.
I have no idea what that means. Multiples of 3 or 1/3? Which one? And what is it called?
It's a
Does it,
geometric sequence.
it's a geometric sequence, class, with A being 1. So you're looking at a geometric sequence with A being 1 and R being 1/3. Okay. So if you said A sub n is A sub 1 R to the power of n minus 1, that means 1 times 1/3 to the power of n minus 1. And you can write it as 1/3 to the power of n minus 1, or I hope you see you can write it this way too. 1 over 3 to the power of n minus 1 makes no difference. Okay. All right. What I want to do, I want to pause and I want you to come up with the rest of the answers. You may have the answer key. I want to see how you arrive at the answer. So we're going to pause the recording for a moment. All right, class. Anybody want to share with us what happens to part C? What do we have? What type of sequence do we have?
Arithmetic.
Okay, very good. Excellent. If it's arithmetic sequence, the first one is 1, and then you need the D, which is 2. And what is the formula? A sub 1 equals A sub 1, A sub n equals A sub 1 plus n minus 1 times D. So now you plug in, and I'm assuming everybody has done it. Okay. And you come up with the answer. Sounds good? Is anyone having problem with part C? Is everybody following that? Class? Make sense to us?
Yes. Yeah.
Can anybody give us the answer to part D? What do you notice? Anyone?
They're squares.
Beautiful. N squared. Simply numbers are being squared, natural numbers. 1 squared, 2 squared, 3 squared, and so forth. Okay. What about the last one? What do we notice? Anyone? Why don't we ignore the sign? Let's assume they are all positive. What do you have? If they were all positive, what would you have? Anyone?
1 over n.
Thank you. Because you can rewrite the 1 as 1 over 1. So 1 over n. Now, let's discuss this piece. Remember what you can write. You can write negative 1 to the power of n, or you can write negative 1 to the power of n minus 1, which gives you the same sign as negative 1 to the power of n plus 1. These two give you the same sign, class. Same sign. But which one do we use? So look at the first one. The first one is positive 1. So we want the first one to be positive. So negative 1 to the power of 1 gives you negative. So that doesn't work. One of the other ones. So if you choose n to be 1, okay, you do get positive and 1 over n. If you choose n to be 2, that works out. So what does it mean? You can choose any of them. Both will work. Both will do the job in this example. Okay, class? If you choose n to be 1, okay, whether you go with negative 1 to the power of n minus 1 or negative 1 to the power of n plus 1 makes no difference. Okay? All right, class. So this would be a good practice for you as far as finding formulas. So here's the next one. The difference equation really deals with what we just mentioned, the idea of recursive format. Okay? So a difference equation or recursive sequence is an equation in the form of a sub n plus 1 is f of a sub n. Okay. And it basically means we need previous one or ones to come up with the new term. Okay. That's the idea behind recursive format. We will look at some examples, but first, let me give you the most famous example that you all have seen before, okay, of this concept, recursive format, okay. Everybody has heard of Fibonacci sequence, of course. Fibonacci sequence is this one. So basically, you start with number 1, and then 1 again. Now you add these two. 1 and 1 is 2. Now you add 1 and 2. Gives you the next one. Now you add 2 and 3, 3 and 5. So you add just 2 terms prior, okay? And in fact, it happens a lot in nature. For example, you look at this 3 and its branches, okay? Normally, it follows the Fibonacci sequence, okay? A mathematician who lived about 1200 years ago from Italy. So the first term is 1, the second term is 1, and then they start adding. Okay, class? What do you add? Previous 2. That's all. First one is 1, the second one is 1. And then we start adding them up. Okay? Let's look at a few examples here. Okay. By the way, I just noticed everybody can see this and it's clear to everyone, right? Because I'm looking at another computer and it seems to be very clear. I hope you're okay with that.
No, it is clear.
Perfect. Thanks. Okay. So we want to find the first 6 terms. And these are recursive sequences. Why is that? Take a look at the way it's been defined. It says, okay, a sub n plus 1. That means the next one is the previous one divided by n. Okay? So a sub 1 is 6. Now what is a sub 2? Okay, is 6. Okay, divided by 1. Okay, is the first one. So this one is 6, right? Now what is a sub 2? As an example, a sub 2, just as an example, would be a sub 1 divided by 1. Okay, which is 6 divided by 1, which is 6. Now, a sub 2. Now you do the same thing. What is a sub 3? Now a sub 3 would be a sub 2 divided by 2. So you divide this by 2 and you get to 3. So I hope everybody can see what's going on. Okay. And you can find the rest of them. But I want to show you just quickly what is a sub 4 is a sub 3 divided by 3. That's how we arrive at 1. The next one is a sub 4 divided by 4. Okay? And then the next one is divided by 5. So I hope everybody can see how we arrive at the answer. Okay. Is everybody clear how we arrive at the answer for part A, class? Is there any questions before we go to part B?
No.
Okay, perfect. Now the second one, part B, says if you want a new term, you need 2 terms, the 2 previous terms. So as an example, if you want a sub 3, okay, if you want a sub 3, that means this will change to number 3. Are you with me? If this is changing to number 3, I'm going to write it here so you understand how that works. So that means you want the next term to be 3, you want n plus 2 to be 3, and n must be 1. Therefore, a sub 3 is a sub 2 plus 2a sub 1. Is everybody following that? And so it's 4. If I want the next one, then a sub n plus 2 means n plus 2 must be 4 and n becomes 2. Now, that means a sub 4 must be a sub 3 plus 2 a sub 2. And you get to 8. Now, I have given you the next two terms, but I haven't gone through the calculation. Everybody can come up with those by going through the calculation. Is everybody clear? For example, a sub 5 must be equal to what? Can anybody tell me what formula? So I want you to use this formula and tell me what I should do. A sub 5 is a sub what? 4 plus 2 a sub 3. Is everybody following that? I need to hear from you, class. Are you following this?
Yes, thank you.
Perfect. And so it's very straightforward. I just want to make sure that we have no problem with that, okay? The last one, part C, we have the first term, okay? So for example, if we want a sub 2, that means you replace n plus 1 with number 2, and that means n becomes 1. So a sub 2 is 2a sub 1 minus 4. A sub 3 must be 2a sub 2 minus 4. And again, as long as you can come up with 2, that means you can come up with all with no problem whatsoever. So I highly recommend you go through the process. I have shown you the work for 2 of it. So I suggest you try to find these 3 on your own by going through the formula that you are going to come up with. This is for the sake of practice, and you need that, trust me, okay? All right. Let's move on. So this was dealing with how to find terms of a recursive sequence. I want to remind you of the summation notation that you've seen, okay? And S sub n is the sum of the first n terms, okay? Sigma is used to represent summation. You got to be familiar with that. You'll revisit that in calculus. We deal with it a lot. Okay. So according to this, that means we are going to start with the first term, a sub 1, because I starts with 1. And then we are adding all the way to n. So a sub 2, a sub 3, all the way to n. So what happens is that we may have, and I is called the index of summation. We may have a finite series such that it ends at the nth term. Doesn't matter how big it is. We may have 10 terms or 10,000 terms. Or we have an infinite series, in which case it just keeps on adding. It never ends. We may have an infinite series. So sequence, we just have a bunch of terms. Series, when we add them up. So sequences refer to a bunch of numbers in some sort of order. So numbers in order give us a sequence. We add them up, it becomes a series. Okay. Now, some of the summation formulas that we should have seen before, and I'm going to refresh your memory, are as follows. Summation of C is NC. They're very straightforward, except some of them. That is because you just add C how many times? N times. This one, you can take the C out. Very straightforward. And this one is just like addition, subtraction. You can do them piece by piece, term by term. And this one is what we just saw from the, arithmetic sequence. We're going to discuss that also, okay? The summation, you remember that from the arithmetic sequence. The other two, we prove it by induction, and you can look at the proof. You can even look up a proof. We do have it in the text or even online. What we want to do, we want to look at a couple of simple examples of this, okay? So that's what we are going to do, okay? Let's start with the very simple example, part A. We want to evaluate this, and it's important for everyone to know the meaning of this. The meaning is we are going to raise 2 to the power of k plus 1, starting with number 1, and we're going to go to number 6. That means 2 to the power of 1 plus 1 plus 2 to the power of 2 plus 1, all the way to number 6. So this is the meaning of the summation. Now, and so I'm assuming everybody can add them up, of course, easily. So figuring them out is not a big deal. Okay, class, for example, this is 64 plus 1, just as an example. We'll take it from there. Part B is really very straightforward. Just A sub j, the summation as j goes from 3 to 6. That means replace it with 3, A sub 3, and then A sub 4, A sub 5, all the way to the upper limit. And that's your answer. So I hope nobody has any problem with the basics that we are discussing here. Okay, class? Does that make sense? Is everybody okay with that?
Yes.
Yes.
Perfect. And so summation is a very, very simple process. This one you don't have to worry about. This is being repeated, class. Okay. Let's look at this example. So let's start with the first one. Can anybody tell me for part C what we can use? Take a look at the bottom formulas that are given to us. How would we use that? Which one of them would you use? For part C, which formula are we using? Anyone?
Is it the first one?
Obviously, perfect. Perfect. NC. So what is N? We have 40 of it. What is that constant? The 5 is being repeated. Perfect. The answer is 200. All right. Now, when you do something like the, and again, it's coming up in calculus, you make sure you have just I in there and you can take out the 2. So this is a very simple step, which is a basic algebraic step. You're distributing, or the reverse process, you're factoring the 2. And now you just use the second formula. Summation of I is n times n plus 1 over 2. So what is n here is number 22. And don't forget we have a 2 in front. And that remains, okay. So these 2 can cancel out this 2. This is 23. And their product is what we are looking for. Now we're going to do the same thing to part E, meaning we cut it into pieces. And that's how you do it. We want to do this so you have an easy time. When you go to calculus 1 and you have a summation, you want to cut it into pieces. The 2 comes out, and the negative 3 gets separated from 2i squared as follows. I hope everybody can see that. Okay, does that work for everybody so far? And now, this is a simple case. All we have to do look at the I squared. We have a formula for I squared. You use that. We have a formula for a constant. You use that. So 2 times, okay. Now notice it's n times n plus 1. And n is 14. N is 14, everybody. 14. Okay, 2. Why 2? Because of this number. 2 is in front, everybody. 2 times n, which is 14, times n plus 1, which is 14 plus 1, times 2n, that means 2 times 14 plus 1 over 6. And then minus this piece is 14 times 3 by the very first equation. Now, of course, I leave it for you. You can just calculate this. Is not a big deal. The 2 drops out. The 6 becomes 3. You just do the math. And it's a simple calculation resulting in the following answer. I hope everybody is okay with this. Sounds good, everybody?
Yeah, thank you.
Yeah.
My pleasure. So let's move on to arithmetic sequences and geometric sequences. Look at the quick examples of those, although we've done that already, but let's look at a couple more examples quickly to wrap this up. Again, I'm refreshing your memory about the definition we discussed about the arithmetic sequence. Now, what I want you to notice on the right side, okay, the summation was given to you, the nth term, I'm sorry, and then here's the summation. S sub n, there are 2 ways to calculate S sub n. the sum of the first n terms is n over 2 times a sub 1 plus a sub n. And as you recall, this is the same formula that's used for the summation of I, okay? That's really arithmetic sequence, if you will. And what you can do, you can replace the a sub n with n minus 1 times d plus a sub 1. In other words, if you replace, let me use a different, now I'm sure you remember, if you replace a sub n with a sub 1 plus n minus 1 times d, a sub 1 plus a sub 1 makes it 2a sub 1, gives you the second formula. What does it do? There are two ways to use the summation formula. You either use the first and the last term, or as long as you have the first term and the difference, it works. So here's a very simple example, okay? The first term is given as 7, that's a sub 1. The difference is given as, by the way, sometimes they just call it the difference or they call it the common difference, okay? It's just to emphasize it. In some texts, they just call it the difference. This is just as good. So with that being the case, a sub 1 is 7, okay? And the difference is negative 3. So if you want to find different terms, okay, all you have to do, just add the negative 3. So the first one is 7, the next one is 7 minus 3, which is 4. Then the next one is 4 minus 3, and so on and so forth. That shouldn't be a problem. If the first one is negative 12, and you're adding 5, then a sub 2 becomes negative 12 plus 5. Okay, which is minus 7. Then add 5, minus 2, then add 5 again and again, again. Okay, these are just a few terms, okay? I hope it is straightforward. What I want to do, I want to look at one more page for tonight. Then I want to talk to you for a few minutes. And that's it. Before we do that, so we are okay with that. I want to spend a few minutes on the next page. I'm assuming we are okay with this, yes? Everyone?
Yes.
Okay. So here's the next question. We are given a sequence, which is an arithmetic sequence. And we are going to find a specific term, in this case, number 13, and the nth term. So first, you need to notice that the first term is negative 3, and the common difference is 1 minus minus 3, which is 4, 5 minus 4, 1, which is 4, 9 minus 5, which is 4. So you really have to see that you add positive 4 to get to the next one. And so now we are interested in finding a sub 13. You can use this formula. N is 13, and a sub 1 is negative 3, and the difference is the common difference of 4. Plug in. Now this is a very simple calculation. I'm assuming everybody can see that. Okay. Now, as far as a sub n is concerned, okay, so we use this one to find that. We're going to use the same thing to find a sub n. So it's a sub 1, which is negative 3, plus n minus 1 times d, which is 4, and simplification will result in the following answer. A sub n is minus 4n minus 7. Okay. All right, class. Let's look at the last question. So again, we have an arithmetic sequence. This time, we are given two terms, and we don't know the first one. We don't know the difference. Why is it that the question is asking for the first one and the difference? Because if we have those two, we pretty much have the sequence. And then after that, it's very easy to calculate S12 or S sub n, or you name it. Okay? So we're going to write the formula for this one. Again, using this very top formula. And we're going to use the same thing for a sub 16. So a sub 8 is a sub 1 plus 8 minus 1 times d, and a sub 16 is a sub 1 plus 16 minus 1 times d. Now, I hope you see that you have a system of equations. By system of equations, I mean you put, use a different color. Let's see, these two together. When you put these two together, okay, a sub 8 is given as negative 16, a sub 16 is negative 40, and now you have to solve for a sub 1 and d. That's a very simple process. All you have to do, keep either the first or the second equation and multiply the other one by negative 1 to get rid of a sub 1. So I hope you see what's going on. We are keeping the first one. We are multiplying the second one by negative 1. Looks like a 4. Okay. I can't make this work, can I? Anyways, and so a sub 1 and negative a sub 1 cancel each other. We have 7d and minus 15d. We add them up. We have negative 16 and positive 40. We add them up. Okay? And we end up with d being negative 3. Okay? Now we put that into any of the original equations and we find a sub 1. This is a very simple case of a system, everybody. I don't believe anybody has any problem solving that. So please understand the process. You're given two equations, two unknowns. Finally, how do we find S sub 12? Of course, we use S sub n. We replace the a sub 1, which is 5. We replace the d, which is negative 3. And this is a simple calculation. This is 6. This is 10. This is 11 times negative 3. And we end up with the following answer. 6 times 10 minus 33. And that's 6 times minus 23, which is negative 138.